Here we have a system of 3 equations and 3 unknowns, so it's going to be a little bit more algebra than if we just had 2 equations and 2 unknowns. So let's see what we can do. We're going to just do the same normal technique, play with a couple until we can get it simplified to less and less unknowns, until we can solve x equals something, y equals something, and z equals something. So let's start with the first equation, x plus 2y minus z equals 4. And the second equation, which is 2x plus y plus z equals negative 2. So we're allowed to play with these in any way that we want as long as we don't break the rules, but if we add these two together, we're already going to eliminate one variable. We'll come back to solve for that variable later. So if we just add these straight across, left-hand side plus left-hand side, right-hand side plus right-hand side, what we get is these will cancel out and we just have 3x plus 3y equals 2. Great. So we've already simplified a little bit. So now let's try and solve for x and y. Like I said, we'll come back for the z later. So if we take this equation and we subtract from it the third equation, then we can do a similar thing and just have another equation in x and y. We can work with those for a little bit. So the third equation is x, 2y, and z. So like I said, we're going to take this equation and subtract this one. So it's x plus 2y plus z equals 2. So we're going to subtract this from there. So subtract instead of plus. So it's easy. They were all pluses. Now we're just saying they're all subtractions. So 2x, this is this equation again, this second equation, 2x plus y plus z equals negative 2. So the second equation minus the third equation. That's what we're doing here. So if we subtract straight across, we get x, we have negative y, these have canceled, and then we're just left with negative 4. So here we had 1 minus 2, and then 1 plus 2, and 2 minus 3. So now we have these two more simplified equations. They're both in x and y only. So now we can treat these like a simpler system of equations. Solve for x, solve for y, and then we'll just have one more step from there. Okay, so what we want to do first is take this equation and multiply it by 3, and then we can start to cancel things here. So let's take this equation, multiply by 3, and what do we get? 3x minus 3y equals negative 12. If we take this equation and we add it to this equation, then we can cancel the y's. So let's take this plus this. Okay. So this is what we came up with before. I'm adding this to it, plus 3x minus 3y equals negative 12. So this plus this. That gives us 6x. These cancel just like we wanted to, and then we're just left with negative 10. We have one equation and one unknown here, so finally we've solved something. So we divide both sides by 6, and we get x equals negative 10 over 6, which just simplifies to x equals negative 5/3. We're 1/3 of the way done now, which is great. We can take this, plug it into here, solve directly for y. So x is negative 5/3, plug that in here. And we can just solve this directly for y. We have one equation, one unknown, so what do we get from here? The 3's cancel, negative 5 minus 3y equals negative 12. Add a 5 to both sides, negative 3y equals negative 7. And then divide both sides by negative 3, and that is just y equals negative 7 divided by negative 3, which is positive 7/3. And we can't simplify it any further from there. So x is negative 5/3, y is positive 7/3. One more step, and then we're done. So what do we need to solve for? Z. We have one variable left. So to do that, we can take any of the 3 equations, plug in what we have for x and y, and we're done. So let's plug it into this first equation. X plus 2y minus z equals 4. So plugging in x, we have negative 5/3. Plugging in y, we have positive 7/3 minus z. that's what we're solving for, equals 4. So if we are able to expand this a little bit, we can just say negative 5/3 plus 14 over 3 minus z equals 4. These have the same common denominator already, which is good. So 14 minus 5, that just gives us 9/3 equals z. Sorry, minus z equals 4. So then we need to get the z by itself. So we need to subtract 9/3 from both sides. So we have negative z equals 4 minus 9/3. Now we don't have common denominators here. We need to have a common denominator. That would be 3. So if we have 12/3, that's the same as 4. Negative z equals 12/3 minus 9/3. So now we have common denominators. We can subtract 12 minus 9 is just 3. Negative z equals 3 over 3. So we have one more step. We have a negative here. We have 3 over 3, which is just 1. So we multiply through by a negative, and we just have z equals negative 1. And that's our final answer. So we have 3 variables, 3 unknowns. We solved in terms of 2, got it down to the answers for those, went back to the beginning and solved for for z there. So those are our final answers. X equals negative 5/3, y equals positive 7/3, and z equals negative 1.